Hello, everyone. In this video, I'm going to show how to write functions in Python. So let's first try to implement the function, which I'm going to call square, where square of x is going to be equal to x squared. So the way we do this is you start off by writing def, and then I'm going to say square of x with parentheses, and then a colon. And then I can say answer equals x star star 2 for square. And then I return the answer. So let's test this out. Oh, need to say square of 2. Square of 2 is 4, just like you would expect. Few things to note here. The basic syntax is you do def, name of function, then parenthesis, name of variable, colon, then you do the body of the function, which is in here, and then you write return, and then you say what you want the function to return right here. We want to make this a little bit better. We can add what's called a docstring. So to do a docstring, you do triple quotes. And in the triple quotes, you explain what the function does. This is another way of doing comments. So you say compute the square of input x. And it's also worth noting in this function, since this function is quite simple, we can actually shorten this a little bit. And we can just say return x star star 2. And this still will do the same thing. And we can test it out on a float as well. We see this works just as well on a float. Now, a couple of things you want to note is that here we returned x squared, but you can also have functions that don't return anything. So to consider that, I'm going to say def print square of x. And I'm going to say print x squared. And I say print square of 2. This seems like everything is working well. And it is. But there's something you need to be careful about. What you don't want to do is you don't want to say my square equals print square of 2. Because if you do this, and then you try to print my square, what you're going to get is you're going to get a none. So whenever you have a function that doesn't return anything, you don't say blank equals name of that function, because there's nothing that's returned. Now let's consider a more complicated example, g of x equals x minus 2. So I'm going to say def g of x. Now I'm going to say y is equal to x minus 2. And then I'm going to say if y is greater than or equal to 0, return y. And we're going to do this because for positive numbers, the absolute value doesn't do anything. Else, well, if the number is negative, we need to make it positive again, so we should multiply by -1. So we say return -y. Let's test this out. It appears to be working just as you would expect. For example, if you plug in 1.5, you're going to have 1.5 minus 1 gets you a -0.5. You take the absolute value, you get a +0.5. So that's it for the first half of the video. The second half of the video is going to concern scope. This is a bit more complicated, so you can go ahead and stop typing now. I've got everything filled in for you. Something we can note here is that we made this variable called y. And y was defined inside of the function, which means it's what's called a local variable. And the thing about local variables is that when the function ends, they cease to exist. So we can't run this line, and we get an error. But what's kind of strange is that global variables, variables defined outside of the function, can be accessed inside of the function. So in this example, I've got a global variable called y. I've got a function called add y, which returns x plus y. And if I run add 2, that works perfectly fine. So the detailed rules of how all of this work are a bit complicated, but the two key points are the following. If you write x equals something inside the function, then x is a local variable. Local variables cease to exist once the function ends. You can, in general, access global variables inside of the function, but the exception is if there is a local variable with the same name. So here, this is that same example we did. We access the global variable y inside the function. This second example, it's almost exactly the same code, but we've also got a local y here. So when we print y, this is going to print the 4, not the 3. This is because in the first example, there's a global y, which we can access inside the function. But in the second example, there are two y's, one local and one global, so we can only access the local y. These issues are not going to come up too much in Math 365, but there is one potential thing we should be worrying about. I'm going to illustrate in the following example. So I've got a global L, and then I defined a function g, which appends the input to L and returns L. So here I'm going to run g of 3, and we're appending a 3 to a list that has a 0, so we're expecting this to say the list containing 0, 3. And that's what we get. So far, everything is good. The issue is that now we've modified this, the global L. And sometimes you want to do this, but most of the time you don't. And what's worse is if I run this function again, we've added another 3 to the global L. And so the rule of thumb for this class is whenever dealing with lists or list-like objects, go ahead and make a copy. So I've got L equals a list containing 0, and then I say L2 is equal to L.copy. And then otherwise things look the same. And now we've avoided this issue where we're no longer redefining the variable L. Yeah, the exact rules, once again, like I said, are a bit complicated. I can explain them to you in office hours, but you don't, for the most part, don't need to worry about them. The one thing you do need to worry about is if you're passing a list or other list-like objects, such as NumPy arrays, which we're going to be learning about later, inside of a function, you should make a copy to be safe. And that's it for this video. Thank you for listening.